Okay students, till now we have discussed 21 problems on the limit of function. Now let us go for some of the previous year questions where in IIT, Karnataka CET and other CET exams the number of questions are asked. That type of questions let us solve in this session. So first let us take f of x equal to x sin of 1 by x and 0. Whenever x is not equal to 0, f of x is equal to x sin 1 by x. Whenever x is equal to 0, f of x is equal to 0. It was asked in 1988 IIT exam. So let us try to solve this. If I solve LHL, RHL, f of a, it will be very lengthy process. So what I will do, directly I will solve limit extending to 0 f of x. Clear? So this is equal to limit extending to 0. What is your f of x? X into sine of 1 by x. X into sine of 1 by x. Here, if I take x term as 0 and sine of 1 by x is having range from minus 1 to plus 1, range from minus 1 to plus 1. If I multiply 0 with any term in between minus 1 to plus 1, your answer will be equal to 0. I think you know what is the what is the range of sine of 1 by x or sin x, trigonometric function. So you know the range of trigonometric function, that is from minus 1 to plus 1 for sin x. Therefore, x into sine of 1 by x will be what? 0 into range in between minus 1 to plus 1. So 0 into range in between minus 1 to plus 1 will be equal to what? 0. Therefore, your answer will be 0. Clear? Here don't try to solve LHL, RHL and f of a. Directly solve f of a only. No problem. Clear? So limit extending to 0, f of x will be equal to what? Limit extending to 0, x into sine of 1 by x. Clear? So 0 into range from minus 1 to plus 1, that is going to be what? 0 into any finite number. 0 into any finite number is equal to 0. Therefore, your answer will be 0. Very simple problem. Now, see the question number 23. Limit extending to 0, x cube cot x divided by 1 minus cos x. Clear? So already we have practiced rationalization method. So here you have to follow rationalization method of denominator. So that will be limit extending to 0 x cube into cot x into 1 plus cos x divided by what? 1 minus cos square x. This will be the term. Clear? By rationalizing denominator, you simplify the steps very quickly. Don't write everything. Limit extending to 0, 1 minus cos square x will be what? Sin square x. Here cot x will be what? Sin x divided, cos x divided by sin x. This sin square x, sin x, 1 sin x from this cot. So it will be sin cube. So that is going to be x divided by sin x to the power of 3, because from this you get 2 sin, that means sin square. From this you get one more sin. So if I multiply all those 3, I will get sin cube. Now the remaining term is what? Cos x, 1 plus cos x. As you all know, limit extending to 0, x by sin x is what? 1. So this will be equal to 1. Cos 0 is 1. Again 1 plus 1. So answer will be equal to 2. So this was asked in 1988 of CBSE exams. So while doing this, please remember rationalization of denominator and don't write each and everything. You just go on skipping the steps. So this is not theory exam. Now let us go for question number 24. In this question number 24, they have asked limit extending to 0, 5 raised to x minus 5 to the power of minus x divided by 2x. To solve this question, students, please you must know one formula, that is limit extending to 0, a raised to x minus 1 divided by x equal to 1. Sorry, that is log a to the base e. That is log a to the base e. Please remember this, limit extending to 0, a raised to x minus 1 divided by x equal to log a to the base e. If you know this formula, you can simplify this particular problem. So now see here, 5 raised to x minus 5 to the power of minus x. If you want to bring these two, a raised to x minus 1 divided by x, what you are going to do? See, here you have x, here you have 2x. In the place of x you have 2x, in the place of x you have x. Both the term must be same. That means this also has to become 2x. So that for that purpose you multiply 5 to the power of x for numerator and denominator. For numerator and denominator. So that will be limit extending to 0. If I multiply 5x to this, it will be 5 to the power of 2x. If I multiply 5 to the power of x to this, it will be equal to 1 divided by. Already here you have what? 2x. No problem. For the denominator also you are going to multiply 5 to the power of x. So it will be 1 by 5 to the power of x. I am multiplying 5 to the power of x for both numerator and denominator. Clear? So now it is in the form of limit extending to 0, a raised to x minus 1 divided by x. This is equal to log a to the base e. So how can you write this? Limit extending to 0, you can write this as log 5 to the base e. Log 5 to the base e into, if I take limit extending to 0 to this term, it will be what? 1 by 5 to the power of 0. So what is 1 by 5 to the power of 0? It will be equal to 1. So your answer will be log 5 to the base e. This is also from IIT exam. Clear? In one of the IIT exams, they have asked this question, limit extending to 0, 5 raised to x minus 5 to the power of minus x divided by 2x. So to solve this, you remember this formula, very, very important. Limit extending to 0, a raised to x minus 1 divided by x, that is equal to log a to the base e. So for that purpose, multiply 5 raised to x on both numerator and denominator. If I multiply 5 raised to x for both numerator and denominator, you are going to get this term. So further you solve limit. This will be equal to what? Log 5 to the base e. This will be 1 by 5 to the power of 0. So your answer is log 5 to the base e. Option A. Now let us go for question number 25. So see this question, very interesting question dear students, and this is also asked in most of the exams in 2000, 2002 and 2006. This is very, very interesting problem, that's why it is asked in most of the exams. Okay, so now let us see this problem very carefully. That is, it is given that f dash of a exists. That means you must know what is f dash of a. Please remember that is f dash of a equal to limit extending to a f of x minus f of a divided by x minus a. This is from your first principle method of differentiation. Clear? F dash of a means limit extending to a f of x minus f of a divided by x minus a. They are saying that this term is given. Then what is limit extending to a x into f of a minus a into f of x divided by x minus a? They are asking this term. I think you got the question. Question is f dash of a is given and they are asking this limit. Have you got my point? So if f dash of a is given means f dash of a is equal to what? Limit extending to a f of x minus f of a divided by x minus a. So now let us solve this. That is limit extending to a for this x f of a. What I will do? I will subtract a into f of a and I will add a into f of a. minus a into f of x divided by x minus a. Clear? Okay, see this. Limit extending to a x into f of a. I am subtracting a into f of a and I am adding a into f of a, and this is as it is, that is a f of x. From this what you can have, that is limit extending to a, take these two terms f of a common, x minus a divided by x minus a. Now separate this term. I will take minus a common. Clear? If I take minus a common, limit as it is, limit extending to a, what you are going to have? If I take minus a common, f of x minus f of a divided by x minus a you are going to have. Clear? Once again I will explain, listen it carefully. This is given, you have to calculate this term. For this I am subtracting a into f of a and I am adding a into f of a, so that I get two different terms. You know that I can add and subtract same term, no problem. So I will get one other term and I will get this term. So now what you are going to have? Cancel x minus a, x minus a. So this will be f of a minus a. This is what? See here, f dash of a. They have already given this. F dash of a is given. That means this term will be what? F dash of a. So you are going to have f of a minus a into f dash of a. Are you clear? So very interesting problem asked in most of the exams. So concentrate on this type of problems, not this problem. They can differ this problem with many types and they can ask. So concentrate on this type of problems very carefully, and they are very interesting to solve also. So f of a minus a into f dash of a. What is your answer? Option A. That is f of a minus a into f dash of a. Okay students, now let us go for question number 26. This was asked in 2006 IIT exam. Okay, for x greater than 0, that means for x positive, limit extending to 0, sin x to the power of 1 by x plus 1 by x to the power of sin x. Please observe very carefully while solving this. If I put x equal to 0 here, sin 0 will be 0 to the power of 1 by 0, that is infinity. 0 to the power of infinity you are going to get. From your very basics, very easy topics, you can say that this is 0. 0 to the power of infinity is going to be 0. Next, you have to solve this. Plus 1 by x to the power of sin x. Check this. It will be in the form of infinity to the power of 0. Infinity to the power of 0. So, from your formulas, you can write it as e to the power of log e to the power of sin x log of 1 by x. Sin x into log of 1 by x. You can write it from your formulas. Clear? Because this is infinity to the power of 0. Whenever you get infinity to the power of 0, please remember L equal to f of x to the power of z of x you are going to have. If this is infinity to the power of 0, this will be equal to e to the power of z of x log of f of x. E to the power of g of x into log of f of x. You remember this for infinity to the power of 0. So now that is where limit is going to 0, no problem. Limit extending to 0. Here limit extending to a. Clear? So limit extend e to the power of limit extending to 0 sin of log of 1 by x. So now you have to solve this. E to the power of extending to 0 sin x log of 1 by x. How can you write sin x? You can write it as 1 by cosec x. That is limit equal to e to the power of limit extending to 0 log of 1 by x divided by cosec x. Now it is in the form of p by q or f of x by g of x, rational function form. So now you apply L'Hospital rule here. Here you apply L'Hospital rule. What you are going to have? Differentiation of log of 1 by x. Differentiation of log of 1 by x is what? 1 by x 1 divided by 1 by x and complete multiplied with differentiation of 1 by x is what? Minus 1 by x square. Clear? Divided by cosec x differentiation is cosec x into cot x. Cosec x into cot x. This is your this is a very new problem to you, so I am solving in detail. Clear? Otherwise we can skip the steps and we can solve, no problem. Limit e to the power of limit extending to 0 1 by x into minus 1 by x square divided by cosec x into cot x. So now what is 1 divided by 1 by x? I will cancel x and x. It will be remaining with minus 1 by x. Cosec x, cot x. Cot x means what? Sin x divided, cos x divided by sin x. Here cosec x means what? 1 by sin x. That means you have two sin, from one cosec x, another one from cot x. Sin x into sin x will be what? Sin square x. That will be cos divided by sin square x. So cos divided by sin square x, if I simplify, it will be in the form of limit extending to 0 minus, as it is, sin square x divided by x into, here it will remain with 1 by cos x. It will remain with 1 by cos x. Further, you take this as sin x by x and sin x by cos x. So now limit extending to 0 sin x by x is what? 1. Tan x, limit extending to 0 tan x is what? 1. So therefore what you are going to get? E to the power of 1 into, here sin x by x is 1, tan 0 is 0. Tan 0 is 0. Therefore e to the power of 1 into 0, you are going to get e to the power of 0 and answer will be equal to 1. Clear? If I differentiate this 1 by x into minus 1 by x square divided by cosec x into cot x, that is equal to limit extending to 0 1 by sin x cos x by sin x. If I simplify that, it will be sin square by x into sin x, tan x. So that is extending to 0, this term will be equal to what? 1. This term will be equal to what? 0. So that is 1 into 0. Therefore e to the power of 1 into 0, that is e to the power of 0 equal to what? 1. So e to the power of limit extending to 0, this term will be equal to what? 1. So option C is your answer. Now let us go for question number 27. That is extending to 1 2x minus 3 root of x minus 1 divided by 2x square plus x minus 3. This was also question of your IIT exam. To solve this, first you have to factorize. Here you have to rationalize. Factorization method and rationalization method, both you have to use here. So for that reason, limit extending to 1, if I factorize this, I am going to have x minus 1 into 2x plus 3. If I factorize this, I am going to have x minus 1 into 2x plus 3. Write this term as it is, 2x minus 3. If I rationalize it, it will be root of x plus 1 divided by root of x plus 1. Clear? So that for x plus 1 into root of x minus 1. See, after factorizing this, you are going to have these two terms. If I rationalize this, you are going to have root x plus 1 divided by root x plus 1. This root x minus 1 as it is. So now, which terms you can cancel? X minus 1 and these two terms you can get cancelled, because a plus b, a minus b, a square minus b square formula, it will be in the form of x minus 1. So directly you cancel root of x plus 1 into root of x minus 1 divided by x minus 1. So if I cancel these two terms, what is remaining term? 2x minus 3, 2x plus 3, root x plus 1. Now use x term as 1 here. What you are going to have? 2 into 1 minus 3 divided by 2 into 1 plus 3 into 1 plus 1. So that will be minus 1 divided by 3 plus 2, 5. 5 into 2, 10. So that is minus 1 by 10 is your answer. So clear? Factorization, rationalization and simplification. So if I factorize, we are going to have x minus 1 into 2x plus 3. If I rationalize, root x plus 1, root x plus 1. These two x square minus b square for a square minus b square formula, it will be in the form of x minus 1. Cancel terms, put x value 1. You are going to have minus 1 by 10. Now let us go for question number 28. F of 9 equal to 9 is given. F dash of 9 equal to 4 is given. Now you have to calculate this particular term, that is limit extending to 9, root of f of x minus 3 divided by root x minus 3. These are the four options which are given. Okay, for this you apply L'Hospital rule. If you apply L'Hospital rule, because it is in the form of 0 by 0, so for that reason you can apply L'Hospital rule. So you are going to get what? That is limit extending to 9, 1 by 2 root f of x into f dash of x divided by, this will be what? 1 by 2 root x into 1. Clear? So from chain rule, if I differentiate this, you are going to get 1 by 2 root of f of x into f dash of x divided by 1 by 2 root of x into 1 by differentiation by chain rule. Don't write each and every step. Cancel 2 and 2. Clear? So this is in the form of f dash of x divided by root of f of x 1 by root x. So x is going to what? 9. So x will be 9 here. F of 9. If I write x value 9, it will be f of 9. F of 9 is what? 9. If I write x value as 9, f dash of 9 is what? 4. So that will be 4 divided by 9, 4 divided by root 9, completely divided by this term, that is 1 by root 9. Clear? Because root x term is how much? 9. So root x means it will be root 9. So if I simplify this, you are going to have how much? 4. So option B is correct for this particular question. Please remember L'Hospital rule, because this is in the form of 0 by 0. Therefore 1 by 2 root f of x into f dash of x divided by 1 by 2 root x into 1 by using chain rule, differentiation by chain rule. So it will be 4 by root 9 divided by 1 by root 9. If I simplify it, it will be equal to 4. Now let us go for question number 29. Limit extending to 0, 2 raised to x minus 1 divided by 1 plus x to the power of 1 by 2 minus 1, or you can tell it as root of 1 plus x. It was asked in those two exams. Okay, let it be. So let us solve this. Using L'Hospital rule, again L'Hospital rule, what you can write? A raised to x differentiation is a raised to x into log a. 1 is 0 divided by, this is root of 1 plus x, that means 1 by 2 root of 1 plus x you are going to have. Therefore, differentiation of minus 1 is again 0. Don't write each and everything. Clear? Here differentiation of root of 1 plus x is 1 by 2 root of 1 plus x. A raised to x is a raised to x into log a. X is going to what? 0. Write 0 here. 2 to the power of 0 is 1. Log 2 divided by, write 0 here. 0 means 1 plus 0, 1. 2 into 1 it will be 2. So it will be 2 into log 2, that is log 2 to the power of 2, and it will be equal to log 4. Clear? Here I am applying log properties. A log b is log b to the power of a. Here I am using log properties. Again, here I am using the differentiation of chain rules. Here I am using L'Hospital. So all this will give you log 4 as your answer. So log 4 is your answer for this particular question. Okay, students, now let us go for question number 30. Limit extending to 0 e raised to sin x minus 1 divided by x. Before going to this, remember this formula, e raised to x minus 1 divided by x equal to 1. Clear? You remember this formula to solve that, then only you can solve it. Now limit extending to 0 e raised to sin x minus 1 divided by, here I will take sin x, means here also I take sin x. Clear? That means you are going to have two different terms, multiplying sin x divided by sin x. How can you write this? You can write it as, here sin x, here x. Clear? So this term with this formula, it will be 1. This term you already know, it will be again equal to 1. Therefore your answer is 1. Very quickly you can tell. This is also one of your competitive exams. Clear? You remember this formula, limit extending to 0 e raised to x minus 1 divided by x equal to 1. Previously we have discussed limit extending to 0 e raised to x minus 1 divided by x equal to log a to the base e. These two formulas we have discussed in this session. So please remember these two formulas, very very important. Clear? Okay students, for question number 31, I will leave to yourself. You try this. Clear? It is nothing but, okay, I will not explain. So you try yourself so that you can build your confidence by solving this type of problem, because this is also one of the IIT exams in 1976. So if you solve this, you can build your confidence on your own. So for that reason, I will leave this one for you as a homework, and I will go for 32. See 32, limit extending to infinity sin x by x. Sir, you are giving this much tough problem to us and you are solving this easy problem. No, like that. How many can answer this by saying it? Most of the students will tell sin x by x limit 1. But observe carefully, limit x is going to infinity. If limit x is going to 0, then it was 1. But here limit is going to what? Infinity. For limit extending to infinity, sin x by x is not 1. You have to check it and you have to simplify. Are you getting my point? So let us try to solve this. I will use substitution method, that is put x equal to 1 by y. So what you are going to have? Y equal to 1 by x. See, x is going to what? Infinity. Y will go where? 0. By substitution, as I discussed in previous class, but while substitution, you have to look all these 3 points. What you are substituting? X as 1 by y. Y will be equal to what? 1 by x. X is going to infinity. If x is infinity, then y will be 0. As x tends to infinity, y tends to 0. Now, replace all the terms. Limit y tending to 0. Here, x is equal to what? 1 by y. So if I write it as Okay, 1 by x is what? Y. So that is y sine of x will be 1 by y. Here y is tending to 0. Again, don't try to solve all the things. Just you take y term as 0. This is trigonometrical function into the range of sine function. The range of sine function, that is finite from -1 to +1. So 0 into finite range will be again equal to 0. I think you got my point. So your answer will be 0. Blindly don't answer it as 1 because here x is tending to infinity. Have you got my point? Okay, students. Now let us go for question number 33. That is limit extending to pi by 4 sin alpha minus cos alpha divided by alpha minus pi by 4. To solve this problem you have 2 or 3 types of methods. I will solve by one method, you try with another method. I will solve it by L'Hospital rule. I will solve it by L'Hospital rule. You try it with other method in your homework. That is limit extending to pi by 4. If I differentiate sine, you get cos alpha. If I differentiate cos minus sine, minus into minus sine alpha divided by alpha differentiation is 1. This will be 0 because constant. Please here your variable is alpha. Your variable is alpha. Sin alpha, cos alpha, alpha minus pi by 4. Here alpha is going to pi by 4. Are you getting my point? So with alpha variable this will be cos alpha. If alpha variable this will be sin alpha divided by what? 1. Clear? Alpha is going to pi by 4. Cos pi by 4 is 1 by root 2. Sin pi by 4 is 1 by root 2. So answer will be root 2. Root 2 will be your correct answer. You try with another method. Already I have solved with L'Hospital rule. You try with another method in your homework. Let us see problem number 34. Clear? So now we have solved 33 problems. Now let us go for problem number 34. So problem number 34 is that limit extending to pi by 2 sec theta minus tan theta. It is asked in 1976. So limit extending to pi by 2. How can you write sec theta? 1 by cos theta minus tan theta can be written as sin theta by cos theta. Clear, students? So now 1 minus sin theta, use trigonometrical formulas. That is limit theta tending to pi by 2. 1 minus sin theta can be written as cos theta by 2 minus sin theta by 2 whole square divided by cos square theta can be written as cos theta by 2 minus sin theta by 2 into cos theta by 2 plus sin theta by 2. So use trigonometrical formulas that you know and you have to simplify. So cancel here one term, cos theta by 2 minus sin theta by 2 term. So remaining term what? Cos theta by 2 minus sin theta by 2. Here cos theta by 2 plus sin theta by 2. Theta is going to pi by 2. So if I replace theta as pi by 2, what you are going to get? Cos pi by 4. Replace theta as pi by 2, sin pi by 4. So cos pi by 4 is 1 by root 2 minus 1 by root 2. It will be 0 divided by root 2. So therefore it will be again equal to 0. So your answer is 0 for limit extending to pi by 2 sec theta minus tan. Students, now let us go for problem number 36. in problem number 36, limit extending to 0, 1 plus x into log of 1 plus b square to the power of 1 by x equal to 2b sin square theta they have given. So you have to find the value of theta. These are the 4 options. Please make this important note. Limit extending to 0, 1 plus lambda x to the power of 1 by x is e to the power of lambda. You have to apply that here. So you will have e to the power of, in the place of lambda, you have log of 1 plus b square, that is equal to what? 2b sin square theta. Clear? These two are inverse functions to each other, or you use the properties of exponential and log. You are going to have 1 plus b square equal to 2b sin square theta. Take 2b on this side, it will be 1 by 2 into 1 by b plus b equal to sin theta. 1 by b plus b will be always greater than or equal to 2. 1 by b plus b is always greater than or equal to 2. For that reason, see here, 1 by 2 into greater than or equal to 2 equal to sin theta. What you are going to have? Cancelled, greater than or equal to 1. That means sin theta is greater than or equal to 1 according to this problem. But we know that sin theta is always lesser than or equal to 1. By solving these two inequalities, we say that sin theta equal to, here you have sin square. You maintain that sin square. So sin square theta equal to 1. So now theta equal to plus or minus pi by 2. Plus or minus pi by 2. Listen once again carefully. That is e log of 1 plus b square equal to 2b sin square theta by using this formula. By applying exponential and logarithmic properties, you are going to get 1 plus b square equal to 2b sin square theta. Take 2b on this side, you will get this term. In this, 1 plus b is always greater than or equal to 2. This is your basic thing. Next, if 1 by b plus b is greater than or equal to 2, this term is greater than or equal to 2 multiplied with 1 by 2, that means this particular term is going to be greater than or equal to how much? 1. If I simplify here, you are going to have sin square theta is greater than or equal to 1. Why? Because your LHL term is greater than or equal to 2. This greater than or equal to 2 is simplified. Greater than or equal to 2 is simplified. Means 2 will get cancelled. It will be greater than or equal to 1. That means sin square theta is greater than or equal to 1. If you get sin square theta is greater than or equal to 1, we know that the range of sin theta is in between minus 1 and plus 1. That is sin square theta is always lesser than or equal to 1. From these two, we have sin square theta equal to 1. Therefore, theta equal to plus or minus pi by 2. Asked in IIT exam as well as KCET exam. Clear? Okay, students. Now let us solve question number 38. F of a is 2, f dash of a is 1, g of a is minus 1, g dash of a is 2. Then you have to calculate this. Already we have discussed one of the problem of this where f dash of a is given in this session in previous problems. On the same way we have to solve this. That is, limit extending to a, g of x, f of a. What I will do? I will subtract g of a, f of a, and I will add g of a and f of a. Write this term as it is, g of a into f of x divided by x minus a. So now f of a common, so you can write limit extending to a, f of a is common, g of x minus g of a divided by x minus a. Take minus g of a common. What you are going to get? Minus g of a is common. Limit extending to a. Then you are going to have f of x minus g of x. F of a. F of x minus f of a, because I have taken minus g of a as common. Now, by this term, you can say that this is g dash of a minus this is g of a. From this term, you say it is f dash of a. From the first principle method of differentiation, limit applying to this will be separate. F of a, it will be separate outside of your limit f of a. If you take this now, you are going to have g dash of a by first principle method. Are you getting my point? By first principle method, this will be g dash of a, this will be f dash of a. Therefore, f of x into g dash of a minus g of a into f dash of a is your answer. Clear? So now, what is f of x? That means f of a. What is your f of a? F of a is 2. What is g dash of a? 2 minus g of a minus 1. Next, g dash of a, sorry, f dash of a, that is 1. So this will be 4 plus 1, 5. So you are going to get answer as 5. Clear? So make sure that subtracting and adding is correct. After that, limit applying is correct. Taking the common terms are correct. So that you are going to get answer as 5. Limit extending to 0 tan 2x minus x divided by 3x minus sin x. This was asked in 1971 and these are the 4 options. So for this, let us solve. Limit extending to 0. So here you have to adjust the terms, dividing by x for numerator as well as denominator. What happens here? Tan 2x divided by x. Here it will be minus 1. For the denominator, 3 minus sin x divided by x. Dividing numerator and denominator by x. So here you are adjusting the term 2. So that tan 2x divided by 2x, it will be in the form of tan theta by theta. So now, if I apply this limit for tan 2x divided by 2x, it will be equal to how much? 1 minus 1 divided by 3 minus 1. So your answer will be 1 by 2. So answer is 1 by 2. Clear? While adjusting the term, be careful. Dividing numerator by x, denominator by x. After that, divide this term by 2, multiply by 2. So this term will be 1 and this term will be 1. Therefore, 2 into 1 minus 1 divided by 3 minus 1. Answer is going to be 1 by 2 for problem number 34. Okay students, let us go for problem number 35. Limit extending to 1 tan of x square minus 1 divided by x minus 1. If I put 1 here, it will be in the form of indeterminates. So for that reason, let us go for L'Hospital rule. For in L'Hospital rule, limit extending to 1, differentiation of tan is secant square x square minus 1 into 2x divided by, this will be 1. If I put x term as 1, it will be in the form of secant square of 0 into 2 into 1. Clear? Secant square of 0 is 0. Sorry, secant square of 0 is 1. 1 into 2, it will be equal to 2. So your answer is 2. Clear? Because sec 0 is 1, it will be 1, 2 into 1 will be 2, 2 into 1 will be again 2. Therefore, your answer is 2 for problem number 35. Okay students, now let us go for problem number 39. Limit extending to pi by 2, 2x minus pi divided by cos x. So what you are going to get? Limit extending to 2, take 2 common, 2 into, minus 2 common, pi by 2 minus x you are going to get, divided by cos x can be written as sine of pi by 2 minus x. So sine of pi by 2 minus x with this term, limit extending to pi by 2, it will be equal to 1. So minus 2 into 1 is minus 2. So your answer will be minus 2 for problem number 39. Okay students, now let us go for problem number 40. Before going to problem number 40, if you look at this, it seems very confusing problem, but see one formula, limit extending to 0, f of x plus h minus f of x divided by h equal to f dash of x, again by your first principle method formula. Clear? F dash of x equal to what? Limit extending to 0, f of x plus h minus f of x. You use this formula to solve this, it will be solved in minimum 1 minute. Clear? So now f of x means a square sine a, f of x plus h means a plus h whole square sine of a plus h. Have you got my point? So if you use this formula, this will be solved just in 1 minute or lesser than 1 minute. This is equal to what? F dash of x, differentiation of f of x. In the place of f of x, you have a square sine a, that means d by dx of a square sine a. Clear? So now you have to differentiate this with respect to a. That will be 2a sine a plus a square cos a. So what is your answer? 2a sine a plus a square cos a. 2a sine a plus a square cos a. Have you got my point? Very easy problem. You can solve it by L'Hospital rule also or other different formulas. So I have solved it with my first principle method formula. So you can solve it by L'Hospital rule also. Try with other methods and get the answer. It must be 2a sin a plus a square cos a. So this is what your answer. Option C for problem number 40. Okay students. After problem number 40, you take problem number 41 as homework problem. It was asked in JEE 2008, limit extending to 2 5 by root 2 minus root x. Try to get the answer. Most of the students are replying me in WhatsApp with answers, so no problem. If you get the answer, reply me as usual.